Hey guys, welcome. I just wanted to give you another code update, I guess, for the bridge optimizer, because something's changed and happened. And yeah, so today is all about costs and the deactivation of the optimization in the driving lane. But that's not finished, but the first step is made in this direction. So, and maybe the biggest improvement is that I can now see what the displacement is of the full model, so with all rods in it, and use that as a constraint for the optimization process. Alright, so let's get started. So here you have the Git graph. Once again, this is a plugin in Visual Studio Code. Git graph, yeah, and so you can easily see what changed or what you did. And every time you have diversion from the main branch, this is me creating a new branch and committing on that. It's mainly just one commit because I just I do the issues, and when I have enough to solve this issue, I commit all that, because mainly, yeah, this is mainly just me working on it, so I see no point in having more commits in the branch just to better separate them. I just do it locally, then commit it, and when it's done, I make a pull request and merge it back into the main, and that's what this is. So you see here the feature which were added. So we have driving lane no optimization, cost calculation, and read displacement use as constraint. And I will go through all them. The first thing maybe is the optimization. Driving lane no optimization. Yeah, so this refers to the rods and load collector and the script builder as well. Alright, let's jump into the code. So, closing graph, I have now my main method here, and we have now the rods. The rods are created here, so this is all known, but here we have the optimization here, the driving lane. So basically what I did was I made the possibility to define a list of nodes, and these nodes I will then deactivate, or rather the rods between those nodes. So driving lane is an empty list, and for I in range of the length +1, that's maybe a stupid idea, but if I had the length 8, I just want to have 8 rod segments rather than points, so point is just one more than the rods, and maybe I have to change that in the future, but right now it is like this. So I have 9 nodes, so I'm adding into this list the indices with the driving lane height and I, so it gets across all X indices, yeah. And I'm appending that to the list, so tuples of that. And then here's the method, rod get rods along path. So this just scans through all rods. Well, yeah, it's a little bit more complicated than that. So I'm giving the grid instance over here, and the path, which is the list of tuples, list of node indices, and now I have the rods, which I want to select here, so an empty list. Now for the coordinates, rather it's the indices, but yeah, the coordinates, I want to append X and Y. So I am getting the node IDs. So basically you have node 1 and 2, for example, and I want the ID of node 1 and 2 because I'm rather indexing that here. So that's a little bit complicated to show, but just imagine you having a grid and you go x2 and y4, and there's the node, and this node has an ID, and you go from 2,4 to 3,4. And 3,4 has the other ID, and so here I'm just appending the IDs, and now I have a list of node IDs. So for example, node 1, 2, 3, 4, And now for every node ID I'm getting, or node ID pair I should say, I'm getting the rods. Because you see here, I'm giving over a tuple, which is the node ID, and the node ID in the next place, and I'm getting the rod based on those two node IDs. And the way I am able to do that is I'm scanning through the dictionary I did over here. Let me see. This is for method. So first of all, I'm checking if node IDs of this tuple is in the dictionary, so as a key value, because when I create a rod, I assign a key, which is starting node ID, ending node ID, as a key into the dictionary, and as an instance, I'm having the rod. So if this tuple is in there, I'm returning the rod, which is finding here, so which is found. But it could be that I swap the node IDs, so they're in different order. And in this case, I just swap them, and else if the swapped ID, swapped tuple is in the dictionary, then I return the rod as well. And if not one of those cases apply, then I print an error that I have not found a rod. So this works for my test case, and this is how I'm able to selecting all the rods. So I'm having the rods here, returning that, and so back here in the main class, we were here in driving lane, so I have now the rods in the driving lane, and now I'm executing this method, toggle optimization. And this is just simply doing a switch of, if it's an optimization rod, then it will get changed to non-optimization, and the other way around works as well. I'm not sure if I'm maybe splitting that up into two methods in the future. That could be, because if you don't know, or there's a lot of error possibilities in this code, I think, because yeah, maybe you have a list and the list is not homogeneous of the optimization. Yeah, so this is a thing maybe to account for in the future. All right, so this is it. This is how I'm toggling the optimization, and yeah, should we maybe just simply, yeah, but I think, no, I just thought about if I show it to you, that to you in the hypermesh model, but I think it's clear from the explanation only. All right, next thing is, let me quickly check that. I think it's the costs. Yeah, the cost calculation. And for that, we jump briefly into here the hypermesh, no, the bridge constructor. So the favorite game here. We are here on our first level again. And the thing is, what's limiting you the most is the budget, right? And the budget is, it's not so easy, right? It's easy, but it's not that easy. Because if you start doing a bridge here, you see your budget goes up, and you have a limited budget. So you cannot make everything. Because I thought maybe that would be a good idea to just load in this the complete structure, but when I wanted to create all the possible elements here, that did not work, unfortunately. Because then maybe that would be also very interesting to, when I have a proposal for a bridge, I could then just simply use the bridge constructor here and build that. Also script based, maybe by clicking and click controls, but yeah. It's not a matter for now, but you see you have a limited budget, and now you can see it changes when you vary the length of your segment. It doesn't differ if you have a solid driving lane here, or if you have a construction. You see, that's 800. So this was 1600, so I'm supposing, oh, It does make a difference. Whoops. Alright, I didn't account for that. I thought it wouldn't, but clearly it does. So let's see, right? So a first segment costs 400, and then additional segments costs 100 more, right? So this is the rule on how you define it. It also works for the diagonals, but here, rather than 100 more, it goes 150 more. But actually, there's a flaw in there. If that costs 400, why does this cost for? Ah, that's why I thought it would not make a change. But actually, this is not a driving lane anymore, right? So this costs 700, which is a little, or should be a little more. No, it does not. All right. So it's not quite exact here, right? But we have to account for the number of segments will largely differ the costs. So for example, here we have 1000, and here it's just 900. But actually, 400? That does not make sense, right? Am I stupid now? Well, here it's 500, and here's another 500. That's okay. But if I start here, so the click alone costs 200, and one segment costs 400 more. So now we're at 600, 700, 800, 900. But this structure costs 900. And I thought that would be way cheaper, because 400, 500, 600, 700 versus 900. So the 200, I don't know where this is coming from. Let's make a structure here and see if it's still valid. Maybe something equal. So we have 1800 here. So first structure is 400, 500, 600, 700. So here it works. This is 700. All right, maybe we have to dig more into it, but the way I'm doing it now is to account for the first segment, which is 300 for me, plus the length times 100. In this case, 1 times the length. So 400, right? Easy enough. And here we have two grids. Two grids, it's 2 times the length, or the cost per length. So 2 times 100 would mean 200, plus the initial 400 would be, plus the initial 300 would be 500, right? Yeah. So let me show that to you in the code. I made a separate class called bridge, which I will use in the future for more than just that, but this is where I started. And the bridge can be initialized and has the grid instance, because it has to know where the things go and stuff like that. So, and now we have this method called calculate costs, and this will walk through the rods. Actually, it just has not only the grid, but also the rods. Yeah, for sure, it has to know that. So the next thing here, it goes through all the rods, and for each rod, the rod is calculated by the cost, or the cost for the rod is calculated. I put that into the rod because I thought it would be better to do so, because maybe we have some other elements in the future, like steel construction or something else, and those would have definitely different cost values. We can check that. Maybe not, this would be embarrassing, but I'm sure they have. Let's jump to a quick level with more than just whatever. So here, well, okay, I will destroy the bridge here. And let's just for a look at things. Let's start with 0. So we have the wood, which is the same as before, right? 400 and additional 100. And the steel is 1000 for the first segment, and then 400 for each segment. Well, steel is pretty damn expensive here. And then we have stones, or this, I don't know how to call that, but yeah. The first segment is 2200, and then 1000 for each other segment. And cables, steel ropes, 600 and then an additional 100. So this will be pretty damn interesting to have multiple different elements. I'm not, and I mean really not sure how to do that in our Optistruct setup, but I can think of more elements or duplicate elements. Yeah, those have to be duplicate elements with different e-modelers and see what the optimizer does there. I'm not 100% sure if there will be something valid, but yeah, let's see. That's the fun of this project. It's a whole new world of exploring. So we were here calculating the costs, and the rods is the method for the calculating the cost for the rod is an instance method of the rod. So if I go here, I'm in the rod class now. I can see now I have a distance calculation, which is also new. So we had a distance calculated by indices, and I wanted to do it with node IDs. So basically I just calculated here the indices and then calculated the distance. So this is also new. And now I'm returning self cost first segment plus distance times the cost per distance. And the distance, I have to say here, is distance in grid lengths. So, and for sure, those two parameters have to be set. And right now, they are just hard-coded here as initial values. We will for sure make them input parameters here, but I'm a bit slow on that because I don't want to have so many input variables. Maybe have a separate method, but I didn't want to change the structure for right now, as we have just one way of optimizing or doing or modeling this approach. So this is how it is for right now. Alright, I think this covers how I'm calculating the costs, and I'm doing that also in the main class. You can see that here, bridge. So just an instance of bridges is being created here, and we calculate the costs here. And I'm not doing anything with it. We will for sure use that when we have maybe our own implementation of an optimization algorithm. Then it would be pretty damn good to use that as a constraint. Right now I'm just thinking if it's possible to use it in anyhow, in any way in the Optistruct way. So in Hypermesh, can I make a user script to calculate this value and then use it as a constraint? If that would be possible, that would be pretty damn interesting, because then we have a base comparison to our own implementation of an optimization algorithm, if I'm ever having the time to do that. But that would be pretty damn interesting. So if any of you would know of such a thing, I'm sure it could well be. I have to ask a friend of mine who works at Altair to about how it may be possible, or even just look it up. Maybe a quick Google search would also help. But let's think about this. If we had a way of implementing our own code or our own cost value, that would be pretty damn good. And I think there is, for sure there are equations, but I think those are not user-defined scripts which can be executed. Rather, it's a combination for equations of values you have in the model. So you could, for example, take the Young's module and multiply it by the with the cross section and divide it by something else and use that as a constraint. I think that is possible, but I don't think it's possible to use own code. But we will see about that. I will ask him and post the results of that in a later update video. All right, costs. So the basis is done here. I can put in an FE model and calculate the costs. Well, I don't even need a FE model for that, but it's just a basic data structure. So what's missing for that to be a whole loop is that I can import a proposal from Optistruct and bring back the data structure, wow, it's late, I'm sorry. And put in the data structure, recognize it, and then calculate the rods, the costs. When doing so, I would be able to do a closed loop, because then I could use Optistruct just as a function evaluator to get me my optimization variables, right? So to see what the displacements are and calculating gradients. That would be pretty fun. And yeah. Well, okay, right. So on calculating the costs, there's the basis is here, but there's still much work to do, and I think the issue is already there in GitHub. All right, last up, and that's a pretty big improvement, is that I'm now able to read a displacement value, or the max displacement value I should say, from a Optistruct run, but Optistruct run not as an optimization but rather an analysis, and use that as a constraint. Because the problem was, so going back into the main class, you have here load step, and here this is new. So I'm now all right, let me show you what the problem was. So here in the script builder, write TCL basic top op min mass. This is one way of optimization, topology optimization. You have to give a node IDs deflection list. This means all the nodes you want to constraint on the deflection. And you also have to give a maximum allowed displacement value. So what the solver is doing, it minimizes the mass, but keeping a displacement less than the threshold or the constraint value you're giving here for those set nodes. The problem now was how to set it. If you didn't even make one calculation, you could end up either way having a much hard constraint, way harder than you need to be. So that would be that the solver makes this thing and puts all the material in it, right? So completely the opposite of what you're trying to achieve, trying to minimize the mass. But even if you put all the elements in it, the displacement constraint is still violated. If that's the case, the optimization setup is screwed, right? You defined it wrongly. There's no feasible design for your set of parameters. So your optimization goal and your constraint. The other way is also possible. If you have just a displacement value which is so large from a constraint perspective, so you're allowing 1 gazillion millimeters of displacement, the solver now can just throw out every element it has for optimization purposes, because first things what we did here was to switch off the optimization with the driving lane, so those elements will always be there, and it will not get a problem for unlimited displacement, but it could just throw out everything. And so your bridge proposal would be, yeah, put a driving lane in it, you're done. We show that to you here with a basic example. Let's go to our first model. So this would be just that, right? And I'm happy this holds. So it will not with the cars, I'm sure, but you see what the optimizer would do? I'm sure. Alright, new record. No, maybe I did this solution once before, but yeah, you know what I mean. So either way, too hard, too soft, both is not good. So for this, you could come up with the idea of just, you have your design space with all the elements, and for a basic shot, just analyze it, see what the maximum displacement of your node IDs would be. And right now I'm thinking, oh, I screwed that up, because I'm looking at the max displacement in the whole model, not just the points where I have the constraints. Maybe I will change that, but you get the idea. So what I'm able to do now is to set up my working directory model file. This all changed here a little bit, but I think the way it's coded is pretty straightforward. So we have a control card for displacement output. So because I need the displacement as a readable output in some file, I will add a control card here. So this is just setting a few TCL parameters for creating a control card. And here the opti value for the format is chosen. So this is pretty damn good, because you have a model name.disp file then, and there's a displacement for every node in there. So that's good. And now I'm just starting to write a script. TCL commands are here. And here's also a pretty neat thing. If you pay attention to Python or want to get deeper into the details, so there's always this method of passing arguments, like for methods. You have TCL commands, and the problem I ran into is that I want to make this displacement calculation, but then back adding the optimization part with the constraint correctly set and then run it again. But if I have the run command already in the TCL commands, it's not good. So I need to make a copy. And this is what other programming languages use as transferring parameters by value, not as a pointer. Because what you're doing here pretty much is that you're giving a TCL commands pointer. Somewhere is that list, it's stored in your memory, and you're giving a pointer. And if you're doing an operation here, it will change the actual list. And that list is also referenced by the script builder. So this is not good. And for that, you're making a copy here. So this is what other programming languages would also name as a deep copy, for example. Yes, so, all right, that's just one nice detail. And you have now this method where you can set up a calc directory different from your model directory, because I don't want to have simulation files there. So write script takes these parameters, and you also can set now a option run. That means it will run the file or run the hypermesh at all, because you saw me changing that with the comment all the time, but that's now not necessary anymore. So if we have run here, we want to have a export and run options. So actually, sorry, that was not perfectly correct. So this is not the writing of the script, because the script is written either way, but you could change if you could have the possibility that you want to run the optimization straight away, or you just want to have your model build up but not run the optimization because you want to look at some things. And this is this run command. So if the run command is set, this add, export, and run options are inputted. And those are, for example, FEA output with data. This exports the .fem file and then executes a Optistruct bat file, which is in your install directory, and gives the parameter for the FEM file and some user parameters you can set. User parameters are pretty important because here you have opt_skip, which skips the optimization. The RAM and so memory, what you give it as a memory, optional. and the number of processes also optional. You could see a bit what they mean in, I think I have put it here, but it's not a complete list. You can dig up Optistruct, the Optistruct from the solver, and then there's a list. Also the help shows that quite well. Alright, back to it. I can now run Hypermesh here with that, and so because I have that in a separate method, I can just comment that out in the top area if I don't want to do that. So I don't have to go down the rabbit hole and comment it out in a method and then forget to switch it back and stuff like that, which happened. So this is a little bit better, and there's a batch mode now. I figured a way out to run it in batch because hw.exe didn't work, but there's not just the HM OpenGL version, but also the HM batch.exe. And this is what I was using, or which I'm using now. And this is working pretty damn nicely. You will see that in a minute. So what I'm doing here, to recap. So I'm building the script with opt_skip. And you see, maybe you noticed, but it's hard to catch. Here, this write TCL basic top op min mass comes below that. So the optimization parameters are not put into the script yet. Rather, it's just the analysis we want to run here to get the displacement value, which we can now use then as a max displacement constraint in our optimization. So you're running that with batch true and wait true. That's important. Wait means the program you're running here, the Python program, will wait until your optimization is done. Because that's important, because else it would go just to the next line and then, oh, there's no file, where's my displacements? And it will go bonkers. So this is important that you set that to true. And then the path to the displacement file is set here, so it's just the model name plus the extension disp. And always change backslashes to slashes, because else Hypermesh will not read it. And then I have another class which is new also, the displacement reader, which is in a file called global output reader. Maybe I will, yeah, for sure, I will add different classes into that file. And it's a pretty simple file. It just initializes, reads the file, you give it here as a path. And then you have a method called read displacements. And this displacements reader will just go through all the file, take in the displacements, and put it into a dictionary. The code is the ID of the node. Key, I should rather say, just not code, it's a key. The key is the ID. And the value would be the translation, which is rather not very open for further things, but it's just a first start. So maybe I will change that in the future and give all the values and maybe make it more sophisticated. There's this method we use here, get max displacement, so this scans through the dictionary, and if the displacement is larger, so we're going with total displacement, but yeah, it's also here the total displacement, so cannot be wrong. With a 0 initialization. So it returns then a tuple of the max displacement ID. This is the node ID, which has the largest displacement, and the max displacement as well. And this is returned, and then you are here. So you have your max displacement, and print that out, and then begins the top opt. So this is like before, but with the new format. So you have your optimization setup, and here I have it set to I am allowing 2 times the max displacement. I have to allow more than there is, because what I'm getting is the maximum displacement when every element I have as an optimization plus the driving lane is in there. So I have to allow more for the solver to be able to take elements out. That's the key point here. And then I'm just starting the optimization, and I have nothing here with batch and nothing with wait. And so you can also see the difference. So I think we'll just start it. And also this changed too. Sorry, that's the one thing I was missing here. So the rod creation worked like this, that I have to give a distance threshold. So it goes to it scans for every other node around, and if the distance from the node to the another node would be less than a threshold, it will create a rod for every. Yeah, so if you have unlimited distance, it will create the node to every other node. But I have now a lower distance as well, so I could, for example, just create elements between 2 lengths of the grid and 4 lengths of the grid. And I want to experiment with that in the future. So for right now, the lower threshold is 0, so this is the basic functionality what we had, and the upper threshold is 3. And well, yeah, we work with that. So let me quickly put a new terminal. Right. So now comes the point. Here's HyperMesh batch working, and you see the output of the batch. I referenced ctemp as a working folder, and I also am pretty harsh on overwriting stuff. So the thing is, it has overwritten the FEM file, but you see here the displacement. This is what I was talking about. Oh, it's too fast. Here are the displacements. You see, that's the annoying thing with the Windows focus. So every time another tab here is put into, the Windows focus is lost. So I cannot work right now, so I have to wait a little bit for the model to be set up. But here are the displacements, and this is read in. You also could see that in the Visual Studio here, because the max displacement is now 6.9 to the power of minus 5. Oops. Alright. And that's about it. So what it did here, it calculated the displacement of the initial value to be 6.9. And now our constraint for the optimization is, let me see, should be 2 times that. Seems about right. So now let's just relaunch the optimization and just see what we are getting. So this is a current state. It's not optimal because what I'm still not quite thrilled about is, well, the duplicated elements. You see, there's an element from here to here, but there's also an element from here to here. And there I have to still find my way how I want to do that. Also, the driving lane has to be a logic. You see, there's duplicate elements, and I think just the elements from here to here to here to here to here to here are non-optimization, so those will be in the model no matter what. That brings the problem that every point here is a bearing. If I would have maybe this rod and then this rod, would mean those 2 bearings would not be there, because I have a rod from here to here, and all the elements pointing to that rod would be pretty damn insignificant. So next for me to do is to have a logic how to put the driving lane. And for me, I think I just make it like that. Less elements as possible and evenly spread. And I don't considering symmetry right now. So this would be my first step. Also those duplicated stuff. This is rather unpleasant. But now, let me just show you what we are getting. Sorry about the menu. A bit unpleasant to watch, but yeah. Alright, let's show the contour. And you see here the duplicate elements. This is still stressing me out. But this is on my list. Maybe I will do that in the next update, definitely. Yeah, definitely in the next update. Right, let's go to the... Alright. Looks rather interesting. But I can see why it's doing that. But I'm hell sure that it did not consider the elements here, the ones with the 1 length, because then Wait a minute. We just have the load here, right? Yeah, it's just a single load. And this is another problem. Yeah. So me talking about that it should consider every bearing is still not valid because I didn't put a force on every, but I'm trying to do that in the next update. I'll just look at it at a ISO view so we can see it a little bit better. Well, yeah. I definitely can see this would be a structure. But let's see. Let's try that out in real time. What if and I don't have to build it up once more, but what if I just would allow much more? Not just 1.3 to the power of -4, but maybe to the power of -2. Let's see. I'm updating that and just putting out the optimization once again. And see, it's rather quick, so we can have a look right now. It just should have less elements. And so you see, maybe also, or get a notion on how important this parameter is. But because it definitely sets your open it up once again, sorry. Sometimes it shows results here and sometimes it doesn't. Maybe it has something to do with the path, but I cannot see anything which is not so good here, but alright. Oops. Here. Let's see. Yeah, you see? The design changes. It's now unfortunate I don't have the other because I have overwritten that. But let's just look at an ISO perspective here as well. Yeah, and here you can pretty damn good see that you have not, or you just have constraint one node. And this is the problem, the main problem of this program right now. Because if I would have more than one node, so let's assume I have a force here and a force there. This would be that I have a rod from here to here, to here, to here, and to here. That would be a whole lot of difference. Because then it would have to constrain that node as well. And there's lots of questions which we can tackle then. Is it good to have just one constraint value or different constraint values because the bending moments are different? Or rather I should say the lengths of the levers are different. So you should constrain that node less than this node. And I think this is also a main purpose of this software or this little fun project. To be able to quickly change and explore different constraints, different rich design spaces. And yeah, so I'm concluding this video for right now. I think, yeah, it has enough new stuff which I have done in the past couple of days. Yeah. So what I was thinking about is doing those update videos. I was thinking about on how regularly I should do them, because I don't want to spam you, because you know it's always like this. If you do something like with coding it's definitely like this. You're going one road, and then you see, all right, this design looks all right, but then again you're changing it, and I don't want to give you every road I have taken and then rather left and made some other changes. But I think it's also good if you can follow me on the process. Maybe I will mark videos as being deprecated in the future, so that you don't waste time on watching me doing stuff which turned out later to be a completely stupid idea. But on the other hand, yeah, I think it's also good if you are able to learn with me on the way. So I'm a little bit torn between two strategies, I guess. So the one strategy is to just accumulate certain changes, and if I'm above a certain threshold, so that it would be too long to cover in one video, then I should do a video, and if only briefly talk about it. And I think this is the route I will go. I will not make every change in here, but the bigger ones, the ones I will do a pull request for, will get covered here on this channel. So thanks again for watching, taking your time and learning with me on this bridge builder. I'm definitely sure it will be a good project in the end. And yeah, I hope to see you back in the next video. If you liked it, you're happy, welcome to subscribe, like, comment. If you have suggestions, or if you're thinking I could do something better, just let me know. I'm always open for criticism and yeah, your thoughts on this. And yeah, thanks again and goodbye.